Hi, Eric. I have a question.
Okay, shoot.
If the universe is discrete, how can we tell what qualities does the universe have to have? And how do we get there in terms of being able to understand it?
Okay, that is the $64 question.
Or the $64,000 question.
Maybe it's even $64 million question. I'm not sure. But that's the big question. If not continuous, and it is granular, what must the properties of that granular universe be? We cannot observe them. It's far too thin. So how can we indirectly ascertain what they have to be? Well, there's only one way of doing it. We have to look at what functions the structure of the universe performs, and from that imply what it must be to perform those functions. Well, let me make this a little clearer. The universe must provide a means for the strings that make up everything within the universe to vibrate freely. How can it accomplish that? The universe must, or the structure of the universe must propel particles of energy through the universe, because particles of energy cannot self-propel. They need a propulsion system. Thirdly, we know from Einstein that the structure of the universe must have the ability to compress around mass energy. That is how his theory of general relativity is, and that's gravity. So we have three major properties, and each of them makes certain demands on what the structure of the universe has to be in order to fulfill the functions that we know are happening. We know that space is contracting around mass energy. We know that particles of energy need to be propelled through the universe. And we know the universe must be a place that provides a six-dimensional structure that string theory requires be available for all strings to vibrate freely. So let's take them in the reverse order and one at a time, okay, and see what happens. First of all, we know from string theory that strings require a six-dimensional space in which they can vibrate freely. Now, if the universe is smooth and continuous, somehow these six dimensions need to miraculously appear at every location where there is mass energy. Well, does a granular universe provide a more realistic model? It does. The universe must be made up of granules. Okay, what are these granules, and is there any evidence that there are such granules sitting around waiting to have a purpose found for them? And there is. We know that almost 3/4 of the universe is made up of what is called dark energy. Now, we know nothing about dark energy except it isn't three-dimensional. So what is it? Well, first of all, It is a particle of energy, which means it is a smallest particle possible. It is only 2 Planck lengths in diameter. We know it is abundant. Now, if the universe is made up of particles, it's got to be a very abundant particle. Mm. It's like saying if the Earth was made of one and the same material, that material must be the dominant material. Mm-hmm. If this is the dominant mass energy, it can only be the structure of the universe. There is nothing else around that hasn't been accounted for that isn't. Well, if it isn't 3-dimensional, how many dimensions does it have? Well, string theory says that there are 6 dimensions and they are coiled up. Now, being coiled up is equivalent of saying it's the size of a particle of energy. So if we take the postulate that it is what has been called the dark energy of the universe, which is the structure, and take the fact that the 6 coiled up dimensions of string theory are in fact the 6 dimensions that are coiled up within that structure, we have solved 2 questions. What the hell is that dark energy doing? And secondly, how can the dimensions, 6 dimensions, be coiled up? Well, they can be coiled up in the form of a particle, and it has to be the size of a particle of energy. And once you have that, now you solve the whole problem. If the universe is made up of what we have called cosmic nodes, which are 6-dimensional structures, the size of a particle of energy, but of 6 dimensions, which means they are far more massive. And it means also that they can provide the 6 dimensions everywhere in the universe in which strings can freely vibrate. So we have solved the question of what is this dominant amount of energy doing? How can the 6 dimensions of space be coiled up? They are coiled up within these particles, for which we have no other accounting as what they perform. And as cosmic nodes, they provide the structure for strings to vibrate everywhere. You don't have to make up how 6 dimensions can be assigned to any point. Every point in space is 6-dimensional. 2 problems solved in one shot.
All
now,
right.
Having gotten through this one, let's see if we can push our luck a little bit further. The speed of light. This is a speed of light which, when it was discovered, was so hugely larger than anything else that Einstein was absolutely rational in saying, well, this is something that is inherent in light. Well, it can't be, because light has certain properties which Einstein also discovered. One of them is the speed of light is absolute. It makes no difference what the speed of the source of light is. It's always the same speed. Now, if light somehow is given this speed, and let's for the moment even forget how that could possibly be,
so
I think I lost.
Well, we're saying the speed of light is considered absolute, but why should it be? Why should it be?
It shouldn't be absolute unless it is propelled. If it is propelled, then the speed of light is not the inherent speed of light. It is the inherent speed of the propulsion system. So what does this mean? The propulsion system can only be the cosmic nodes. And we have assumed that the cosmic nodes are 6-dimensional and are vibrating. So if we take the fact that the vibration of the cosmic nodes is what transfers the energy to the strings, we know in a rational way how this light acquires that speed, but light acquires that speed. It doesn't inherently possess that speed, which Einstein assumed. Now, if light acquires that speed has to be exactly the same as the vibrational speed of strings. Now, if that is true, we can measure the speed of light. We cannot measure the vibrational speed at which strings vibrate. So by just making this connection, we have found the indirect way of establishing what the vibrational speed of strings is. And it is very likely that because from completely other considerations, people have in cosmology have established that the vibrational speed of strings must be, quote, close to the speed of light. Now, why won't they say it is at the speed of light? Because nothing can be at the speed of light. And the problem is they're starting with an a priori assumption, which is almost correct, but not quite correct. They are not taking into account of the fact that it is this vibrational speed of strings, which is also the vibrational speed of a cosmic node, because we assume that it has to vibrate in and out. But if it vibrates in and out, it can transfer that speed. And once it transfers the speed, we can measure that speed. And now we know what the speed of vibration of a cosmic node is. And that is the vibration of each and every string. And now we have found probably the one of, if not the most important constant in the universe, at least one of them. What is the inherent vibration of strings? And we know it because of the fact that it transfers its energy to the linear speed of light, and we can measure that. So we have established the big secret: at what speed do strings vibrate? They vibrate at exactly the same as the linear speed of light. And the reason that the speed of light is absolute is it is being propelled. So all of the questions about how light traverses the universe is solved, and it solves a heck of a lot of other system questions, because it isn't just particles of what we call light. It is particles going all the way from particles of radio or mass energy all the way to particles of the greatest mass energy that we only use for treating cancer patients. That is a dynamic range of 1 trillion times, light being roughly in the center of that range. How in heaven's name can anything give the same speed to this unless it is a structure that does it? A structure like a cosmic node can do it because it receives the inputs of the particle of whatever it is. It doesn't make any difference. It can be from one end of the mass energy scale to the other. It absorbs the particle, and then in the next blank time, it releases it, and it returns the same energy that it got when it came in. Now, this can go on. This is an indefinite loop, but it is from cosmic node to cosmic node to cosmic node. And each cosmic node sends it along the next journey of its way. And this way, we have solved two things. We have solved what is the inherent vibrational speed of strings, and how is it that light and all other particles of energy travel at precisely the correct speed for their mass energy.
So the speed of light is not arbitrary.
The speed of light is not arbitrary, and it can't be arbitrary.
And it can't be arbitrary, and it's an indicator of the clock speed of the universe. I think
it is the observable manifestation of the inherently unobservable reality of the vibrational speed of strings. The clock speed, the clock rate of the universe, debatably the most fundamental constant in the whole universe. And we have found it by looking at its interaction with light in the process of trying to find light. Now, the importance of this is mind-boggling. And I don't know if we have time to do it right now, but in the next section, I would like to take that up.
All right. Thanks, Eric. This was great. I appreciate your time today.